Okay, so we start again for the last session for today. So I'm the next speaker for the 3 talk remaining. And I will talk about LustreHSM, which are already been cited for in several talks today. So this is not the first time I talk about this project, but it has been a while since I've made a real talk about it. So I know that some of you don't know the details of this project and how it's working and so on. So I will first present it to explain how this is working, what's the architecture. I know some of you are really thinking about to set up this and work with it, the new components. A few examples of how this works, what could be done with that, and at the end, the current project status. So, it's been a very long time since I've presented this project. It was a couple of years ago. It has now a lot of different changes, a lot of different Lustre companies, a lot of different events which have delayed it. But now it's there. It's very close to be finished and will be available very soon. So, so after several modifications, rewrites, adaptation, and so on, it has been landed fully this summer. Last month, for I think early August for the last patch. So as Peter said, it will be available in Lustre 2.5, which will be available hopefully at the end of October, so at the end of next month. So, what's LustreHSM? The main idea behind LustreHSM is to use Lustre as a cache in front of an HSM. So it's to bind them together. When I said HSM, it's the main target, but in fact it could be more or less any external storage. We will use the best of each world, meaning that we'll use the capacity, the bandwidth, the scalability, high performance of Lustre, and the possibility to use tapes and cheap storage and very big capacity of HSM, and trying to have this together. One of the main ideas behind that, like what we plan to do for CA, by example, is to use this kind of project in our center-wide Lustre file systems. I've already seen there is several sites this morning which presented that there is such kind of big Lustre file system in the center of their computing center. It is something which is becoming more and more common in the different computing center, and this will be a very good. This project will be very nice for this kind of file systems. The several features we plan to do, which now is not plan to do. The main features of this project could be resumed with 3 of them. The first one, what we call archived, meaning copy data from Lustre to your backend, to your HSM. When you have done this, you have now a copy of this in the backend, so you can remove the data in Lustre. You will keep the inode, but you won't have the data anymore, so we have more space to be used for other files. This is what we call release. And at the end, the ability to restore this file when you need them. So when your user is trying to access the files that have been released, it's called restore. Adding to that, we'll have a lot of policies management to control automatic migration and automatic purge, these kind of things. It will be supported to import an existing backend. This is something I think will be really useful, but because most of people which are interested by that already have an HSM with a lot of data in it. So it will be really interesting to import this directly in a freshly formatted Lustre. And this is also the case for disaster recovery scenarios when for some reason you lose your Lustre file system and you want to restore it using what you have pushed in your backends. So you will be able, in this case, only to restore what have been archived before the crash, of course. If there was some data in Lustre which have not been archived yet, it will be lost. This is possible through 3 new components that are adding in the Lustre architecture. The copy tool, which is the main tool responsible for talking with Lustre to your external backend. Policy engine, so to manage the policy and automatic migration, kind of things. And the coordinator, which is new threads on MDT. So I will go in details about all of this. So this could be more or less the big picture of this project. So you see on the left side, the traditional Lustre components, clients, OSSEs, MDS. And on the right side, we've got your HSM. So what we have added to bind this together is first a copy tool, which is a user space program, which, as you can see, will access the HSM and also access Lustre through client. Client we call agent, but it's more or less standard client. It's just a role rather than really something technically different. And the coordinator is the component which is gathering all requests sent from clients, from standard clients on the left side, and trying to dispatch this to all the available copy tools. So we've got this main idea of requests coming from clients and data moving between Lustre through the copy tools. The other part is the policy engine. So as I said, this is also a user space program which will be running on the clients. It will be using clients API, liblustre-like API, or liblustre API, and POSIX API of Lustre, standard Lustre client. So it's watching using the client, what's happening in the file system, it's monitoring it, and it's triggering actions based on the policies he has, like archiving and so on. So the first component is the copy tool. This is a really important part, as this is the only program who really know how the HSM is working. So it's the interface between Lustre and each HSM. As each different HSM product has its own API to access it, that means that we will need one copy tool for each HSM product. There is 2 of them available right now. First one is the POSIX copy tool. POSIX copy tool is already included in Lustre. It will be bundled with Lustre and available as in other Lustre tools. This copy tool is kind of generic one, and it can talk to any external storage, external backend that support a POSIX API. So this could be used for HSMs which support POSIX access, like DMF through XFS, for those who know. I think that some QFS support also POSIX access. But this is also if you want to use something else than an HSM. If you have some NFS backend for some reason, you can use this tool. Or another Lustre file system could be used to run this through the POSIX copy tool. And the second one is the HPSS copy tool. So as the name says, it's dedicated to HPSS. It's a HSM we are using at CA. So we have developed it. And it will be available for any HPSS site. As this is not open source, we cannot really distribute it, but anybody who has a HPSS license can have this tool. There is other HSMs that will be supported. We are working with several vendors on this topic. SGI is really involved. They are working on their copy tool, I think right now. They have made some prototypes in the past, but they were more or less waiting for the final code and the project being more stable and more ready. So now they are finalizing this, and I think you should ask them, because I cannot really tell this, but I think they should have something quickly. But ask AGI if you're interested in this. And we're also working with Grow Data, which is a German company working on different storage products. One of them is OpenArchive, which is an HSM, and they are also following this project closely. I have contact with other vendors, which are maybe not so advanced that those ones, but I think there will be other tools available next year quickly. This is not such a big deal to code a copy tool if you have specific needs. The second, so as I said, there's another component which is the coordinator. Actually, the kernel thread running on the MDT is responsible for resizing all HSM requests sent by clients and storing them for resiliency, and being able to resume those requests if the MDT crashes or things like that. And it will also dispatch and try to manage the workload on the different copy tool and trying to balance this. So that's very important components, and you have different tunings to control how copy tool will be working with their HSM. Actually, thanks to the port being done on Lustre 2.5 for landing, it was not the case at the beginning of this project, but now this is DNE compatible. That means that you can use LustreHSM with several MDTs. This is a simple implementation so far. This way for improvements. But just to give you an idea, if you're interested by this, I will say that traditionally, the Lustre file systems that will be used in front of HSMs normally don't have such workloads that they need several MDTs. But I don't know, maybe someone will try to do this. So in this case, we'll have, if you have several MDTs, you will have one coordinator per MDT, and each copy tool will connect to each coordinator. Each coordinator will only manage files of its own MDT, and he will do the same. He will gather requests, store them, and dispatch them to copy tool. So there is a simple balancing mechanism for the copy tools. This could be improved, I think, to have something very, a cluster-wide balancing system for the load on the different data movement copy tools. The policy engine for this project is RobinHood. So there has been already a lot of information given about RobinHood. So for LustreHSM, policy engine is a specification. I mean, there is no full requirements to use RobinHood. Policy engine is responsible to do automatic migrations. That means triggering requests independently of what users are doing. And it will do this using POSIX API and Lustre APIs. So theoretically, any components can do this if you implement it. So far, RobinHood is the only product which has all of this implemented and available. So as what RobinHood was doing in the past was really close to what we need, it's a reason why we updated and we adapt RobinHood to fit the policy engine needs. So that's really cool because we have what we need for LustreHSM, and we have also all the other cool features that you have seen this morning and in other talks offered by RobinHood. So about policies, I think it's really nice to be able to define very fine-grained and detailed policies about what you really want to happen in your file system. So RobinHood can make policies based on any file attributes, what get from stats, but also Lustre-specific attributes, even extended attributes. This could be really nice if you want to implement your own rules. You can tell your users to set some specific extended attributes, and RobinHood can use this value for its own policies. All those attributes could be combined with Boolean operators, so you can have something really detailed and really complex if you need so. And is basing its migration on LRU list, which could be tuned also through the policies. So I go directly for the examples about this. So this is a simple configuration. It's just to give you more easily an idea of what you will need if you want to make, by example, a testbed using Lustre 2.5. So this is something really simple. You can have a lot of more components in it. So I've used only one client, one MDS, one OSS node, but you know you can put here as many nodes as you need. What is important here is that I've added a specific client, which is the agent. So as I said, agent is only a role. It's the same client as any Lustre client. Just there is a detail about that. And this client can access, is connected to the Lustre network, for sure, but also connected to the HSM. So this is really important to have such client which will be able to run the copy tools and so to move data between HSM and clients. You also need a place to put RobinHood. RobinHood is using MySQL as backend. So in this sample schema, I've put RobinHood on the same nodes as the POSIX copy tool. In fact, it could be a separate node. Maybe it could be a good idea. For this, only set up a simple service client, which runs the copy tools and RobinHood. We said that in Lustre 2.4, there was already some support for LustreHSM. So in this case, it means that the client here could be a Lustre 2.4 client because there is support for this kind of access, but this client could not be. Here, if you want to have some administrative actions to do, you should not. You need a Lustre 2.5 client, and all of this should be Lustre 2.5 too. So yes, Lustre 2.5. RobinHood is compatible with this version of Lustre starting with 2.4.3, and all other version will be available. So 2.3 was released 1 or 2 months ago, I think. So a few examples of commands and what could be easily done. So here I'm using LFS command. You all know about this command, and I'm asking Lustre to archive this file. So this will trigger a request to MDT to the coordinator. Will store it and pass it to one of the copy tools who will read data from Lustre and push it in the HSM backend. And when this will be finished and will be acknowledged by the copy tool, you can check with HSM state command that now the file is flagged as archived on archived ID 1. I did not say that Lustre can support several backends. When you've done that, you are now able to release the files. That means removing the file data from this file and make room, gaining disk space for Lustre. And this does not involve any copy tool. This is internal of Lustre. It will go directly to the MDT and it will do what's required. And so it's synchronous. And when this is finished, you can check with the same commands that now the file is flagged as released and is no more using blocks on the file systems. But the file size is still correct. And so now there is no more data. If some users try to access this file and try to read it, automatically request will be triggered to MDT and goes to copy tools who will restore the file and so read the data from the HSM, put them back in Lustre, and enable access. So this will block, waiting for the file being fully restored. And when this is done, the access will be granted normally. So from a user space point of view, it will only see some I/O that will be really slow, and that's all. And you can check here that now release has disappeared, and we are back in the state that we were here. Two examples of RobinHood policy. Quite simple, yes, simple examples for standard needs, I would say. So RobinHood is managing file sets, class of files, and policies for migration of purge. So here we've got an example of a file set. So we can see that the file set is only applied to some tree of the file system and only for small files below 1 megabyte. And there is a special hints. We'll talk about this after that. And here is the, you can have as many of them as you want. You can have a lot of them, so just an example here. And for policies, first there is two whitelist rules who say, okay, those files, I don't want to archive them at all, either because they are zero sized, so it's not really useful. As I said previously, you can have special extended attributes to, just an example, which are available to users, by example, to control how policy are behaving. And we also whitelisting logs file, by example. We don't want to archive them. And so in this case, we have two policies at the end. One policy was applied only to the file set here, and which has special conditions, so we try to migrate them quite soon. It has not been modified for 6 hours. And at the end, you can have also here a couple of them. And at the end, there is a default policy which applies to all of your files. And in this case, we're just checking for the for files which has not been modified for 12 hours. And we have the default migration hints here. So this value here will be passed through Lustre directly to the copy tool. And Lustre will not interpret it. It has no meaning for Lustre. It just passes it directly to the copy tools. And it is the responsibility of the copy tool to do something with it. So it's copy tool dependent. And by example, for our HPSS copy tool, we give this value. So for those of you who know HPSS, it's class of service. So it's different kind of file set in HPSS, which will have different policy in HPSS. So that means that small file will be using a special class of service, and all the other file a different one. Just an example of how you can have interaction between the policies there and the copy tool, and so your HSM with some HSM specifics information. So the second policies, which is really important to have something working, is a release policy. So that means RobinHood needs to release file and make room and gain free space, avoiding your file system being full. As it is a cache in front of your HSM, it's quite sure that you will have more space in your HSM than in Lustre. So you need some way to do this. And RobinHood is doing this based on monitoring the disk usage in Lustre. You can do this either for the whole file system or by OST. This is what we are doing here. So if one OST is used above 90%, RobinHood will trigger a request to put this below 80 in this example. So that's the rule to trigger those actions. And the policies is here. So we have also some whitelisting. So by example, the very small file, we don't want to release it. It won't be useful. And by example, a root file, we don't want to release them too. And there is two policy also. One which is applied to a specific file class, which is not shown here, where file will be released really aggressively. If the file has not been accessed for 1 minute, we can release it if we need to. So what's important here, this is applied only if we need some space. If the file system is not full, this is never applied. And by default, we apply this to any file which has not been modified for 1 hour. You can put whatever you want here, days, months, what you like. So the current project status, so as it was said this morning, as I said previously, client-side code was landed in Lustre 2.4. That means that 2.4 client is partially compatible with this. As I showed previously, you cannot do exactly everything you need on a client, but all you need for a compute node, by example, is already there. And all the other parts of the code have been landed this summer. I would like to thank Intel for all the work they have done helping us landing this code and bug fixing and working on several aspects. And they have done a very nice work, and they are still doing this. We are still working on testing and debugging this, so it's not totally bug-free. Should be by the end of October, hopefully. And Lustre 2.5 will be the next maintenance release, as it was said too. So this is really a good thing for LustreHSM, because so many sites is asking for this for years now. Okay. Do you have questions?
Two things. So one, you mentioned multiple copy tools, or sorry, multiple archives. Does that imply that you can have multiple different HSM storage systems as well? In other words, different copy tools associated?
Yes. In fact, I don't have a slide showing this, I think, but maybe that one it's okay. So yes, you can have here several HSMs, and you will need several clients with different copy tools. And when copy tool starts, they're registered with a different ID to Lustre. And when you archive, you have to tell which ID you want to use.
Excellent. Second question. You mentioned in a few times today, actually, with RobinHood, whether policies based on last access time. Does that mean that you need to run Lustre with the A time enabled?
Good point. No, I don't think so. I think you can tweak.
Yeah, I guess the question becomes, does the last access time show up in the change logs? And I don't know the answer.
Good point. I'm not sure. We should ask Thomas, I think, for that. He will know the answer. I think it's not mandatory. I don't think so. I think it's okay. But better to check, I think. Okay. No, I don't think it's needed, because I think there is no time in change logs anyway, so RobinHood should be using another things to handle this.
I also have two questions. First one, how do you involve the quota system in there? Because if you release files,
that's
do
a
they
good
still
point.
count to the quota of the user or not? Or if someone waits till everything is swapped out, does he suddenly have this double quota?
You can set up quota for inodes. I think it will be fine. You should set up.
Doesn't really help if you do 1 terabyte files.
If you enable quota for data, I think it's something crazy, because really it's really something difficult to handle quota in Lustre when you have a backend behind this, because ideally you need something for both, handling both of them, and it's not so easy. There's a lot of really tricky cases, and if you enable quota only in Lustre, the only things that you can do right now, you will have things very weird, like if you try to read a file, users can have quota exceeded errors and things like that when you try to read, so it will be quite weird. But I would not advise to try to enable quota for block quota for in this kind of configuration.
So in the end, you can't use block quota if you use HSM, more or less.
You can, it will work, but you must be careful of what you are doing.
It kind of works.
It depends what you mean, but really it's not a simple question. It's not, oh, you just have to do this and it will be easy. So, really, because from admins don't want the same things. For some admins, they want to say, okay, quota which is important for me is what is in Lustre. I don't care what is in the HSM. Some will say, oh no, that's not the case. We need to handle both. And this is not something so clear. And so we just have to implement this and everybody will be happy. And so trust me. We have think a lot about this issue, and this is not there's not one easy solution.
Second question, which has to do with some of failed HSM experiments in the past when we tried this in Cologne. Acceptance of HSM systems, because most users can't really see whether a file is released and needs to come back from tape, for example, or is still on transient storage and you can access it immediately. Is there any way of finding out if a file is on permanent storage or tape storage apart from LFS?
HSM state?
Yeah.
No. That's the
Because
official way to check
at least
this.
with our users, this will only result in why does my data not come back? And they will really reread everything every few hours or something like that to have them permanently on disk, which kind of negates the benefits of HSM, of course.
Yes, it's what we said, that you can use this command. You can tell them to check, but maybe the point was that they don't want the file to be released at all, and they are trying to access them all the time
They don't want to learn a new command or simply be sure that the data is there when they try to use it.
Yeah, you can try.
Which is what we tried in the past, but it didn't work. They really started to do random I/O on tape archived files. Not a good idea.
You said the coordinator was resilient against failures. Is it tracking activity of the agents? What if an agent fails?
Yes. Is tracking agents, is rescheduling requests. If some copy tool is failing, for example, there is policies to tell that you don't want to do this. For example, if you think that when an agent is failing, it is really a bad case, and some admins need to check why. So there is automatic rescheduling of requests or not, and there is information in /proc to check this. I think we'll have to stop here for questions. You can go to see me at the end of today's talk if you have more questions. We need to go to the next talk to keep the scale on. Thank you.